The f of x means, okay, if you have any kind of function, whether it's something squared or something with the square root, it really doesn't matter what kind of function, these rules apply to all the kinds of functions. Okay? So if it says f of x plus a, then what happens is that the graph moves up 2. Not 2. A. Sorry. So on the next little thing it says x squared plus 2. So up 2 just means I go up 2 and I draw a parabola. Because that's what a parabola looks like. So on the next one where it says square root of x plus 2, I still go up 2, but I don't draw that parabola thing anymore. I draw a little sideways almost parabola where there's only half of it. So I go up 2 and put that point, and then I draw that little sideways thing. So the next one, whenever there's something on the outside, then that means down A. So in this graph right here, that means I'm going to go down 2, and then I'm going to draw that parabola upside down. That's not right. Just mean I went down 2 to draw it, sorry. Okay, and then so the next one, I go down 2, and then I draw that little sideways parabola thing. Okay. What does f of x plus a, like x plus a in parentheses, mean?
Right.
It's not right, it's left. Because when we were doing these, we noticed that they were opposites. So it's left a. So if I'm going to do this one, I'm going to go left 2. And then I'm going to draw my parabola.
What about the next one?
Well, the square tells me that it's going to be a parabola. Whatever the function is, that's like the square in this problem. In this problem, it's the square root. And it just tells me like the shape. So the square root of x plus 2 means I still go left 2, but I draw that little sideways shape. What's the next one going to do? Alright, it's going to go right. So I'll go right 2, and I draw my parabola. I know it's a parabola because of the square. The next one I go right 2, and I'll draw the little sideways thing. Okay. The next one. This is where we were putting the negative at the beginning on the A. It flipped it. This one was where there was a flip, so instead of going up, it flipped it down. Okay, so we're just going to call that a flip. So it starts at 0, 0. I don't move it left or right or up or down or anything because there's no numbers there. It's just that negative on the outside, and it just flips it down like that. So on the square root one, instead of going up like a square root one does, it goes down. So it's like coming down this way. It still goes to the right, so that part doesn't change. It just flips it over. Okay. The next one is kind of a different thing because we didn't talk about this one, and it's hard to tell with a parabola what it means. But I'm going to call it a horizontal flip, and it's not very common. You won't see it very often. But what happens is, so here's a parabola, a normal parabola. A horizontal flip means it kind of goes side to side. Well, if I move the parabola, the left part of it, if I move it to the right, it's that. If I move the right part over, it's that. So that particular thing doesn't really change the graph at all. Okay, so it's kind of a, I don't know. Kind of a weird thing, and you won't see it very often. A horizontal flip just means I'm flipping it over around this way, sort of around the y-axis if you want to think of it that way. Okay, so for the square root ones, it does change it a little bit. See, the original comes up this way. So if I flip it, it's going to come over this way. And so it would look like that. That's the only time that the direction of the square root is going to be the opposite way. Most of the time they're going to go to the right, either up or down to the right. Okay, what about the last two? What do you think the last two are doing?
The width.
It's what?
The width of it?
It's the width of it, yes. And it changes when it's a parabola, it's wide and skinny. And this is wide and skinny, but they're opposites. Okay? So we're going to call it something different. All right? This is called a vertical stretch. And this is called a vertical compression. I'll do my best to explain this. So here's a parabola. Okay, and what I'm going to do is I'm going to take these points on the parabola and I'm going to stretch them up.
Make it skinny.
So it makes the parabola skinny when you stretch it. Okay, well here's the square root one. When I stretch it, it's not skinny. It's wide. So with the parabola, it makes it really skinny when you stretch it. With the square root one, it makes it wide. Okay, so let's think about the compression. So here's my parabola again. And instead of stretching it up, I'm squeezing it down, and that makes it really wide. But with the square root one, if I squeeze it down, it makes it skinny. You see that? Does that sort of make sense? And so we can really say skinny and wide, although if you can figure it out and can say it, that's fine. But it's not consistent. It changes. Okay? So what happens for the parabola on this one is it's really skinny. And what happens here is it's really wide. For the parabola on the compression, it's really wide. For the square root one, it's skinny.